Fine. In the last class, we had discussed so many concepts. Now we'll see. These are all the concept from the beginning. We have discussed the analog circuits, the digital circuits, and amplifiers. In digital circuits, logic gates, and all we have discussed. And we discussed the Arduino basics. What is a microcontroller? What is a microprocessor? Difference between them, and the concepts of the Arduino, and the structure of the Arduino program, and especially the Blink, which is the first program, and the connections of the LED, some of the applications, what and all we can do using this Arduino boards, and a few circuits also we discussed. The LED blink and the traffic light control system we have discussed. Now today we'll discuss the servo motor. The servo motor is nothing but one of the DC motor which is being used in the most of the industrial automations and robotics concepts. You can observe now in this diagram. A servo motor will have three wires, or the three pins will be there. One is the ground, and the positive or plus VCC, that is 5 volts we try to connect. Yeah, you can observe three wires here which are coming out of the servo motor. Black wire, and red wire, and the yellow. Okay, the black is as usual the negative or the ground, and red is the positive, that is 5 volts or VCC also we call it as, and this is the output. Actually, this yellow color, through yellow color, it's going to send the instruction to the servo motor. Okay, we can connect that to any one of the pins of the Arduino. As already we know, there are 14 pins are there. In this diagram, pin number 9 is being used. Okay, we can connect it to the 10 or whatever it is, but we have to mention in the program. Okay, now let us see the program. This is in the diagram on the Tinkercad. So you can just go through the program. It's very simple. Already, many of you might have practiced the writing the programs and simulating some of the circuits and all. As we know, it has the setup block and the loop block. Just I have made it in two sections here. Uh, we can, as we know, in the setup block, we will have to configure which are the pins we are using, and which are the input pins, which are the output pins, and all. So in this simulation, or in this project, we can say, only one pin we are using, that is pin number 9. So we can observe here in the beginning of the setup block, we are going to include the header files. Usually how in C program, yeah, we use. So in the same way, some of the special the header files will have to include in the program also. This is a variable, that is a position. This is a pos. We can give any name here, user defined it is. The initial, that is a int, is the variable name. That is a pos is the variable name, and the integer kind. And initially it is made to 0. Okay, and to which pin we are going to make the servo is what this servo is the command, and the servo 9. So it is a optional, it is user defined. This is second part of the instruction. We can connect it either 10 or whatever the program, I mean whatever the pin we can connect. And here in setup, just we are going to give the instruction here. The servo is the command, and which pin. So that pin is going to be attaching to the pin number 9. Okay, so this is optional here. Yes, because underscore we have used, so we need not use in pin number here, but here it is must in the bracket, the before the semicolon. That is very much important. Which pin we are going to attach is very important. Okay, fine. This is the loop block. You can see these are the commands, which are the command lines. Step the servo to 0 to 180 degree. We can give the steps here to rotate to the in clockwise direction, or the anti-clockwise direction, or from 0 degree to the 180 degree, and reverse also the possible. There are two blocks are there. You can see two using the two for loops we are using. This is the one for loop, and this is the another for loop. So carefully observe this position, which is the variable already declared in the beginning, is going to be initialized 0 once again. So already it was 0, not a problem. And compare the value of this position, whether it is less than or equal to 180 degree, and increment in the step of 1 degree. You can give any name. As you give the more number, so it will be more faster. Here it is a bit slow. I have given. Okay, this is the comment line. Tell the servo to go to the position in a variable position in servo 9. Uh, you can see here. uh, this command, or what it does, it will send to the pin number 9, because already we have initialized to the pin number 9. Right, for the servo, write the value of the position. In the beginning, the position value is 0. If it is less than 180 degree, do this. Means 1 is sent to, means 1 degree will rotate to the right from the 0 position. Then it will be incremented by 1 degree. Then again compare. Now it is 1 which is less than 180 degree. Do this. Okay, and again now it is plus 1. Increment this. The position value is 2. Compare this, less than 180 degree. Send 2 to the position. So 2 degree now. So increment it, becomes 3 degree. It is less than 180 degree. Send us 3 to pin number 9. So it will rotate 3 degrees. So this keeps on executing till this condition fails. The sense, when it is greater than 180 degree, so the condition fails. uh, it comes out of the loop of this. So in between each and every degree, this delay of 15 millisecond is going to be executed. We can increase this delay also, not a problem. Once this condition is the fail, means it is already rotated the 180 degree. Now it will be in the same position, so we have to reverse it back. So for loop, now the initial position exactly reverse, initialized to 180 degree. So already it is 180 degree position was there. Now we have to decrement this. Okay, so we have to compare whether this is greater than or equal to 0. Okay, if it is true, do these two. This send it 180 degree to the pin number 9 is already 180 degree, not a problem. This is 15 millisecond. Decrement this, there is a 179. So we again, which is greater than 0, send it to the pin number 9, 15 millisecond wait, and decrement this and compare this. It's true, do these two. So this keeps on executing. I think the most of the uh, people are aware of this C program. The concepts is fine. So this keeps on rotating. Once it is done, again it will come back to the first for loop. So it keeps on again. Once it becomes 0, it comes out of the second for loop. It will enter into the first for loop starts. So all the instructions which are present in the loop are going to be executed continuously as long as the power is supplied to the Arduino. Okay, so in the first for loop, it will rotate from 0 degree to 180 degree, and in the second for loop, 180 degree to 0 degree, and again 0 to 180 degree, 180 to 0 degree. So this keeps on uh, executing continuously. Okay, so now we'll see the simulation now. It is running now. This is the same program what I showed now. Stop it. Yeah. I'll start it. You can see, observe now from 0 degree to the 180 degree, and again back to this keeps on executing continuously. Okay. Uh, Still few are joining.
Sarji, I have one small question, sir.
Please, sir.
Can I?
Please, sir.
That's great, sir. Thanks so much. Basically, if I want to make this rotate continuous, because through the full 360 degrees, so I feel that PWM, what it is mentioned, the other pins. So I think
Yes.
that is the kind of input pulse width modulation is where it can control the degrees.
Exactly,
Correct,
sir.
sir? Otherwise,
Exactly, sir.
yeah,
Yes, sir.
because
Yes,
the
sir.
endpoints of that servo,
Hmm.
it can vary many servos only through about 170 degrees, as you were rightly saying.
Yes, sir. Yes, sir. So
So we can.
we can make it 360 grads. Not a problem, sir.
Oh, that's nice.
We
That's
can.
nice.
So these are usually in industrial automation. These are going to be used widely.
Okay, okay.
In robotics also, to make
Ah,
the movements of the different arms or whatever the robot parts are there. So we try to use these the stepper motors as well as these servo motors in particular degree or particular steps to rotate, sir.
okay,
Yeah.
okay.
So thank you.
So that's where we select that PWM and then we try
Exactly, sir.
to increase the
Exactly.
angle. Okay.
Exactly, sir. Yeah.
Yeah. Thanks.
Now, yeah, fine. Uh, I request all the participants to join a little bit early because once I start, usually I'll wait for 5 to 10 minutes in the beginning. If you keep on trying there, once I start explaining here, I think you will be in the waiting list. So please don't mind. If I see the waiting list, then only I can allow it. Otherwise, you'll be there only. I request all of you to join at the earliest, please. Yeah. The next is the relay, the interfacing. You can see the diagram. Yeah. This is the relay. Basically, a relay is a electromagnetic switch. So it is a switch kind only, but we operate it using the principle electromagnetic induction. So as we know, this is the coil. Okay, when we pass the current through this, any induced EMF will be developed across it, and due to the magnetic field, a metallic contact will change its position from one location to another location. So you can observe for every relay, there will be the two outputs will be there. One is I'll come back to this slide a bit. I'll show you. Yeah, fine. You can see here, this is the relay how usually it looks like. You can see between this is coil 1 and this is coil 2. Okay, in the sense this is, you can observe here, the diagram is here. This end coil, this is the coil, this is terminal 1 and terminal 2, we can call it as. Okay, these are the terminals of the coil inside, and here in the output side there are the three terminals are there. This is common, and this is the one terminal, and this is another terminal. So we call this as the normally open, and this is called the normally closed. The normally closed, you can see this the common is connected to this point. Means when it is off, in the off condition, or in uh, not energized, so the connection will be pin number 3, what the common is connected to the normally close. Okay, when we apply the voltage here, this voltage depends on the what kind of relay it is, whether it is the 5 volt relay or a 6 volt relay, 9 volt relay, 12 volt relay, 24 volts, depending on our application. We try to use the different relays. Okay, so basically we go for the relay whenever to control the high voltage devices and high current devices. Of course, the transistor also can be used as a switch. So we can not get, we have seen in the beginning in the logic digital circuit, it is also going to act like a switch, but it carries a very the minimum current, so in milliamps, but that do DC. But when we want to interface the heavy devices which carry high DC current or AC current, so we go for the relays. But relays can be operated using the Arduino or any the relay drive circuitry. Okay, hope you understood this the construction. Now, when we apply the required voltage, say for example, if it is a 5 volts relay, if you apply the voltage, the 5 volts between this pin number 2 and 1, okay, this the current start to flow through this coil, it becomes electromagnet. So the connection will change from uh, this pin 2, that is normally closed, to normally open. Means this uh, circuit will be closed, this side, this becomes open. So we try to, here I will tell you the terminals of all these. This is this pin, the coil N2, coil N1, and this is common, and this is normally closed, this is normally open. So usually whenever we try to use this relay, we try to connect the load to the normally open. In the sense, when the device is off, the load will be connected to pin number normally open. When the voltage is applied, that is 5 volts is applied to the coil, that becomes closed. So the common will be connected to this normally open, so that circuit will be closed. So now I'll explain the mechanism, how in real time application, how it is being used in a circuit. The same thing, the exactly the relay, how it looks like. uh, as I said, it has three pins are there. One is common, normally connect, NC, normally open. So these two will be shorted when it is off, okay. And when it is on, the this pin, the common or the COM, in depending on the relays, they will write it as C or COM, anything is fine, that will be connected to this. So it becomes on and off in the sense. So here you can observe, there will be, to control, to make it on or off, you have three more pins are there, okay. One is the 5 volts. That depends on, if it is 5 volts, we have to apply the 5 volts here. If it is a 6 volt relay, 6 volt and 12 volts, and depending on the what kind of, you can observe here, uh, somewhere it will be written as, so what kind of relay it is. You can see here, 0.5 volts DC means, if you apply the 5 volts for this between uh, the coil, so it becomes on. To connect that 5 volts, we have two pins. This is the VCC and the ground. Okay, this is the signal. So usually this is the digital signal. Either it will be 5 volts or 0 volts. That voltage, the signal, we can apply manually 5 volts, or we can make it to operate by a Arduino or any microcontroller. Of course, the digital pin off. Okay, so these two should be connected to a power supply, the 5 volts power supply. So when it is 0 volts, this will be off. This C will be connected to normally connected as usual. Okay, when this signal is the 5 volts or high, okay, digitally high, so this will be connected to this. So I'll show you how we try to use in a real time load, and I'll come back to the first circuit, how it works. Yeah, you can observe here now, this is an Arduino, okay, and this is the relay kit. And suppose I want to switch on uh, the bulb, okay, so directly AC voltage we can apply. So this is the way how we connect usually. uh, to connect the bulb to the AC, so directly we connect from bulb to this switch, okay. But here, break one wire, either that or this. There is no polarity for the AC. Break one wire and connect one wire to the broken wire 1 and 2, the common, and the other into normally open. This is NO connection. It's normally open, okay. So as usual, there are three pins to control the operation of the relay. That is 5 volts and ground. So as usual, red is connected to the 5 volts and this black is connected to the ground. And this pin, which is the signal in the previous slide, that should be connected to the one of the Arduino pin. Okay, so as we know, the digital pin of the Arduino will send either 0 volts or the 5 volts. Okay, when it is 0 volts, this will be, suppose this is already plugged to the AC. Okay, when the Arduino output pin, sorry, this is the Arduino output pin. This is 0. Okay, this relay will be off, and the circuit will be off in a sense. This common will be connected to, this common will be connected to normally connected. So the circuit is not closed. So when the Arduino will send the 5 volts on this pin, that 5 volts will appear on this signal pin, and it will supply the 5 volts to the coil inside. So automatically this common will be connected to normally open. So this circuit will be closed and the bulb starts to glow. Okay. Uh, Now let us see how this relay works. So once again, I'll go back to the the previous slide. Yeah, this is the relay. To make it operate, we use a relay drive circuitry. Okay, a relay drive circuitry will have an NPN trans or any trans PNP or NPN, it doesn't matter at all. A transistor, a base register, and here one LED. So this is optional, just to indicate whether the relay is on or off, something just indication, and a collector register for this circuitry. Uh, and this is, as we know, this is basically act like a the NOT gate, uh, how we discussed in the beginning. So whenever this voltage is zero, the transistor will not conduct. It will be in cutoff region. Okay, there is no current passing from here to here. So there is no voltage drop across the coil. So it will be zero. So it will be off only. Okay, when this input voltage is 5 volts, when it is 5 volts, the transistor goes into saturation. Okay, when the transistor goes into saturation, it starts conducting. It is equivalent to shorting this collector to the ground. In the sense, this total 5 volts is going to appear between this point and the ground. Between this point and the ground, the two paths are there, the register and LED, and this coil. So the same 5 volts will be between this point and this is the ground point. This act like the ground point when once the transistor is on. So therefore, all the 5 volts will appear across this. It becomes an electromagnet. So due to the electromagnetic induction, this position will change from common to here. So the circuit will be closed. Therefore, the bulb starts glowing. So this is the way how it works. At the same time, this register will control the current flowing through this LED, and the intensity depends on this. This is the optional. The LED is optional. Okay. Let us see the program. Using the same Blink program I had used for this. Yeah. So this is a setup block, which is the pin mode, pin number 2, the output, because we have to send either 0 volts or the 5 volts to the pin number 2. If we send 0 volts, that 0 volts will go to the transistor input. Uh, so that 0 volts will not switch on the transistor. So no 5 volts to the relay. So relay will be off. So the light will be off. Okay. If it is 5 volts, or it will send the 5 volts to the uh, transistor base terminal input, and it goes into saturation. It conducts, and the 5 volts will appear across the coil, and it becomes on. So it is a output. So here you can see the loop. So all these are going to execute continuously. So this will write to the pin number high, means 5 volts. The 5 volts is sent to the uh, 2, pin number 2, that will drive the transistor input. The transistor goes into saturation. The 5 volts will appear across the coil, and the position of the common will be close to the uh, common will be connected to the normally open circuit, becomes closed, and the bulb will be on. So this is the way how it works. And this is a 10-second delay I have given. So 10 milliseconds is nothing but 10 seconds delay. And again send to the same pin number 2, low, which is 0 volts. That 0 volts will drive the transistor, the base terminal into, will apply, make it as 0 volts. Nothing but the transistor goes into cutoff, so it will become off. So the 5 volts will not appear across the coil. So again back the uh, relay common terminal will go back to normally connected. So circuit becomes open. So light becomes off. So this again 10 milliseconds, sorry, 10,000 milliseconds, or 10 seconds delay. And again, so it keeps on on off continuously. So depending on our requirement, say same technique can be used. So instead of the bulb, we can connect the fan. Okay, so once we connect a fan, so we can connect the input side a temperature sensor. For example, if the temperature goes beyond 30 degrees centigrade, the fan should be on. Okay, otherwise the same technique can be used for the street light control system. You put this light sensor. If the light's intensity is less in the evening, so it has to send a high signal to the particular pin of the Arduino. That should drive the relay circuit, and relay circuit will drive the DC power supply or the existing AC. Doesn't matter. So these are the some of the techniques how we utilize for the real-time application. I think it is going to off again. Another we'll discuss again 10, 15 minutes or 20 minutes. Please log in once again using the same ID and password. So I'll repeat. Please log in again. The session will get over using the same password and ID. We'll discuss one or two circuits once again.